Hey guys, we have notes here for 13-3A. It's the second part of 13-3 dealing with Radian measure. These are the notes, and this is going to be the homework for Wednesday and Thursday, 422 to 423, okay? So make sure you guys are submitting your homework and showing, please show all your work. If you just give me the answers, guys, I can't give you credit for that, okay? All right, I'm gonna try to make these as quick as possible here. You guys obviously can pause, go back and look it over as many times as you need to. All right, the whole idea for today is we're gonna draw an angle in standard position and find the sine and cosine value exactly. Remember, that means exactly. So we don't want any decimals. We're gonna use pi, we're gonna use root symbols, stuff like that, okay? All right, but the whole idea is to be able to navigate and move around the unit circle, okay, guys? So you got to get good with, these are kind of like our navigational directions here, and we're always going to start with this initial side, okay, of my angle, and we're going to move around the unit circle. All right, so just remember, cosine is the x value, sine is the y value, okay? All right, so I don't want you necessarily, I guess you can if you have to, and it's fine, I guess, for this lesson, is using this unit circle. Remember I said in previous videos, you guys should have your own unit circle all filled out, and that's gonna assist you in doing these lessons and being able to navigate around the unit circle a little bit more easily. If we were in the classroom, I know you guys wouldn't like me for doing this, but I wouldn't let you use that because I want you guys to kind of learn these positions on your own. All right, so cosine of pi over 4. Remember, pi over 4 is radian measure. It's not degrees, it's radian measure. And if you remember, okay, pi over 4 is right here. It's 45 degrees. It's pi over 4, okay? All the way around the unit circle is 2 pi. Halfway is just pi. So that's going to help you out as well. All right? All right, so if we know that we're going to make this angle here, we're going to rotate in that direction, and we moved pi over 4 radians. Okay, that's how far we moved. We're going to land right there. All right, since this is a 45, 90, it's going to be root 2 over 2, root 2 over 2. Just remember, we created that triangle, and we went over root 2 over 2, and then we went up root 2 over 2. All right? I made this triangle before. I showed you guys this before. Now it's flipped over to the other side. Okay, so it's going to look something like that, just a bigger version of it. But remember, this radius here is 1. This is root 2 over 2. Okay, so that's what that looks like. All right, so we went over root 2 over 2 and then up root 2 over. And that's the exact answer. So we want the cosine. So obviously the cosine is going to be root 2 over 2. That would be my answer for that one. Okay, over here for this one, all right, what is that? 7 pi over 6. So remember, 7 divided by 6 is more than 1. Okay, so it's going to be over here somewhere, okay? 7 pi over 6 is going to land right there, okay? It's also equivalent to 210 degrees. So that means I'm going to rotate all the way around, all right? My reference angle, okay, right here, is a 30-degree angle. So this is a 30, 60, 90, okay? So if we remember, all right, we're gonna look at this ordered pair. All right, this is the shortest side right here, -1/2, negative root 3 over 2. So we're over negative root 3 over 2 and -1/2. Remember, this is in the third quadrant there, so it's going to be a negative and a negative. So we want the sine, which is the y value. So we would say the sine of 7 pi over 6 is equal to negative 1/2. All right, but we're using that radian measure to go around the unit circle, not degrees. Okay, all right, down here, we want the cosine and the sine of, we'll just do cosine. We can just cross this part out here, guys, of 4 pi over 3. All right, 4 pi over 3 again is, if you think about it like this, we're starting here. If I were to rotate around to here, that's pi. 4 divided by 3 is 1.3 repeating, right? So that's going to continue down to right here. So 4 pi over 3. And by all means, you guys, if you need to, if you want to use your unit circle, find the 4 pi over 3, and you know exactly where it's going to land. Okay, but if you want to try to challenge yourself, you know, don't look at that right away until you absolutely need to. All right. Okay, so once again, we created this reference triangle here. All right, again, it's a 30, 60, 90, negative root 3 over 2, negative 1/2. All right, so the ordered pair for this point, oops, let's see if I can move that up a little bit, okay, is going to be negative 1/2, negative root 3 over 2. All right, so I want the cosine, so my answer would be negative 1/2. So the cosine of 4 pi over 3 is equal to negative 1/2. All right, okay, 5 pi over 4, once again, that's going to be over in this region here, because 5 divided by 4 is 1.25. So it's going to be landing right here. So 5 pi over 4, it's going to land right there. Now, just in the position where it landed, we know that this reference angle is a 45, 45, 90, right? So you know, or you should know, that we're going to use root 2 over 2, and it's in the third quadrant, so it's going to be a negative and negative. All right, we want the sine. In this case, it really doesn't matter, but the sine is that y coordinate. So the sine of 5 pi over 4 is negative root 2 over 2. All right, good deal. All right, if you turn the page or the second page of your notes, let me read through this. All right, you guys remember what coterminal, okay? They share a terminal, two angles that share a terminal side. To find coterminal angles when they are measured in radians, you can add or subtract 2 pi. Instead of, remember before we added or subtracted 360 for degrees, now we're going to add or subtract 2 pi because we're dealing with radians. When graphing angles in standard position, we will want the angle to measure between 0 and 2 pi radians. Okay? All right, so let me show you what this is. All right, so we're looking for, so what's the cosine of negative pi over 3? Well, since we have a negative pi over 3, we can add 2 pi to that. Now, 2 pi is 2 pi over 1, okay? In order for me to add fractions, you need the same denominator. So this is going to turn into negative pi over 3 plus, if I'm going to multiply this right here by 3 over 3, it's going to be 6 pi over 3. Add those up, and I get 5 pi over 3. All right, so what that looks like down here, all right, and you can think of it one of two ways. Negative pi over 3 is just from here to here. All right, oops, sorry, from here to here. All right, because if you look up here on your unit circle, pi over 3 is a 60-degree angle. So if I go negative 60 degrees, if I go this way, all right, it's going to land right there. So if I went this way, this would be negative pi over 3. If I went this way, it would be 5 pi over 3. Okay, so if you wanted to get to this spot on a unit circle from starting in the standard position there, you could either go negative pi over 3 or you could go 5 pi over 3. These two are coterminal with each other. All right, So again, we're gonna look right here. All right, this is gonna be positive 1/2, negative √3/2. So ultimately, we wanted the cosine, which is the 1/2. So the way you could write your answer, you guys, the cosine of negative pi/3 is equal to 1/2. There you go. There's your answer. Okay. Excuse me. Let's look over here. Sine of 7pi/2. All right. Sine of 7pi/2. So if I have, all right, 7pi/2, I'm going to subtract 2 pi. All right. Okay. So I'm going to multiply this by 2/2. So it's going to be 7pi/2 minus 4pi/2, which gives me 3pi/2. All right? So 3pi/2, 3 divided by 2 is what? 1.5 pi. So if I'm starting in my standard position, if I go 1 pi and then 1/2 a pi, it's going to bring me right here. Okay? All right, so this, if I rotate in this direction, all right, that direction, that would be 3pi/2 here, okay? Now, if you're looking at the original 7pi/2, all right, 7pi/2 is what? 3.5, all right? So if I went around 1, 2, 3, and then 0.5, I'd land in the same spot. Okay, so it's almost like starting here and going, all right, here's 1 pi, 2 pi, 3 pi, 3.5 pi, which is the 7 divided by 2, or 7 pi divided by 2. All right, so you guys should know what this ordered pair is. It's 0, -1. We want the sine, so we want that. So you'd say the sine, oops, of 7pi/2 is equal to -1. All right, but what I want you guys to get out of this is how we took a multiple rotation. So this rotated a few times. Actually, it rotated one, okay, 1 3/4 times, okay, and then we got it down to a measure of an angle that was between 0 and 2 pi. So this was coterminal to that one, but it was between 0 and 2 pi, so I was able to graph it a lot easier than I was the 7pi/2. Okay, all right. Let's see here. All right, the sine of negative 11pi/6. All right, so this is negative 11pi/6. All right. So what I'm going to do is add 2 pi. So a negative 11pi/6. I'm going to add 2 pi to this, okay? Remember that 2 pi is over 1. So I'm going to multiply this one by 6/6. So negative 11pi/6 plus 12pi/6, which is 1pi/6. Now this angle right here is between 0 and 2 pi, all right? And it's in a positive direction, and it's gonna land right here. Looking at my unit circle, all right, I know that this right here is a rotation of pi/6, all right? All right, and this ordered pair right here is going to be √3/2 and 1/2. Now we want the sine, so we would say the sine of negative 11pi/6 is equal to 1/2. Okay, awesome. All right, for this one, guys, I'm gonna skip this one, but for this one, if you just kept on subtracting 2 pi, you'd get 5 pi. subtract 2 pi, and you get 3 pi. Subtract 2 pi, and you get just 1 pi. So again, that's what we're trying to get to, is an angle that I can graph very easily. 1 pi lands right there. This point right here is -1, 0. We want the cosine. So the cosine is -1. All right, and then the last page of notes, you guys. All right, we have this thing called an intercepted arc. All right, this right here, S. This is the intercepted arc. So if I am rotating, okay, the measure of the central angle, okay, this is radians. All right, this is going to be the length. What I'm looking for is the length of this intercepted arc right there. Okay, all right, and the way we find this is we take S is equal to R times theta. Okay, that little sign there is theta. That's just the unknown, or whatever that degree is, okay? All right, so S is the intercepted arc. Oops, RC. R is radius. Okay, and theta, measure of the central angle in radians. All right. Okay, so let me show you how this little formula works here. This little equation works. All right, so if I want to figure out what the length of this intercepted arc is, what's the length of S? Okay, so we know that S is equal to the radius. Oops, sorry. Is equal to the radius. In this example, the radius is what? 6 inches. So R equals 6, and theta equals 7 pi over 6. Okay, all right. So I'm going to take R, which is 6. All right, I'm going to multiply that times 7 pi over 6. So here's my radius times the measure of that angle in radians. Okay, now remember, we can cross reduce those 6's there. So I'm left with just 7 pi. So we could say S is equal to 7 pi, or approximately 22 inches. 22 inches, because we just multiply 7 times pi. So length of that intercepted arc is 7 pi, or 22 inches. All right, guys, we're going to end the notes there. Again, using this formula is not very difficult. All you need to find is your R and your theta. For some reason, if they gave you the S and they gave you one of the other two, you could find any of these, okay? Just set it up into the equation and solve for that variable. All right? Okay, guys, so your homework is that third, see if I can find it for you guys. I thought I had it sitting here. Yep, I do. Is right here. This is going to be your homework, okay, guys? Look for 4B, 13-3. All right, and you're just going to do 1 through 21. All right, on the back. It's front and back. You guys, I need to see the work. All right, for some of these are pretty simple. You can use your unit circle. That's fine. But for these ones back here, okay, I need to see work. All right, okay, guys, have a great day.